First off, let's get down some definitions. A polynomial function is a function of the form f of x equal to all of this notation.
Is that actually a thing?
It is actually a thing.
And what do you use?
I want you to write down this function notation, and then I'll explain it. So this notation discusses, okay, we're going to deal with functions in this function notation from here on. And this a sub n, or anytime you see an a with a subscript, this is a place of some type of number, some type of coefficient. Or, in the last case, this would be where our constant number is. When you see an x to a number, it's going to be x to some type of power. And then x to a different power. X to a first power. X to the 0 power. But there's some stipulations when we discuss polynomial functions. First off, the leading coefficient, that a sub n, the leading coefficient can't be 0. So when I discuss a leading coefficient, it's going to be something besides 0. The exponents have to be whole numbers, and the coefficients have to be real numbers. Some more important details that we're going to use to graph, we need to know what the leading coefficient is. And it's going to be the very first coefficient times x to the biggest power. This a sub 0 spot, so whatever's in this last spot that does not, well, it doesn't have a variable with it, like x, this is called the constant term. And then n is the degree of the polynomial. That's something new, very new. We never really talked about the degree of a polynomial. But if we have a quadratic function like x squared plus x minus 1, if we had a quadratic function, the highest degree is 2. The highest exponent is 2. So here are the important pieces of these. The leading coefficient will tell us, wait a second, are both of my arrows pointing up and up? Is one of my arrows pointing up? Is one of my arrows pointing down? Is it a reflection? This constant term, the constant term will always let us know what our y-intercept is. And the degree will kind of let us know its shape. Standard form. Before we can even recognize what the leading coefficient, the constant term, and the degree is, we definitely need it in standard form. And the standard form of this polynomial function, or this equation, is when its terms are written in descending order of exponents. And there shouldn't be an apostrophe here. That's my mistake. Standard form of an equation is when its terms are written in descending order of exponents. So if I see an x to the 4th in a problem, or, my bad, an example of standard form would be an x to the 4th term, then an x to the 3rd term, then an x to the 2nd term, then an x term, and then a constant term. Those powers have to be in descending order. This is in your textbook. You do not have to copy it all down, but kind of going through this notation. We've seen constant functions before, but instead of using f of x, we typically had a y here. And instead of a sub 0, we typically would have a number there. Let's talk about what like y equals 2 would be. Let's identify polynomials. I want to do this sort of quickly, so going through these directions, we're going to decide if the function, first off, is even a polynomial function. We're going to practice just writing in standard form, identifying the degree, the type, and the leading coefficient. We're going to do this quickly. What I want you to do is write down example A. Write down example A, and we're going to put its pieces off to the side. First off, we're going to put it in standard form. Standard form would be putting the highest degree first. So I look through these terms and figure out, okay, which one has the highest exponent. That's what I mean by highest degree. Whichever one has the highest exponent goes first. So I notice, okay, negative 3x to the 4th, that 4 is the biggest exponent. So that's going to be written first. And then you go with the next highest exponent, the quadratic term. Then you go with the constant term. Once you can identify it in standard form, then you're ready to state its degree. The degree lets us know kind of what the shape is, and we'll get to the shape in a moment. But degree is the highest exponent, and the degree of this one is 4. And then the type, just to practice the words. I would never test you over this, but to get used to the words, 4th degree polynomial is called a quartic. You can kind of see quarter in that wordish. Leading coefficient. Leading coefficient will let us know if it's a reflection. If A is positive, or if the leading coefficient is positive, it's going to be regular behavior, but if it's negative, that's whenever we deal with those reflections. And the leading coefficient in this case is -3. Next problem, you've got to determine, okay, if I'm going to write it in standard form, what goes first? Because we don't know this exponent, it could be 4, but it also could be 0. Because we don't know what this exponent is, it's actually not a polynomial function. Not polynomial function. So I can't put it in standard form and discuss a degree or anything.
So, is it no solution?
Next one, we determine, okay, which one's the biggest exponent to write in standard form. We've got the x squared, and then we've got an x. And then the smallest degree is this -1, but freeze. Here's the thing about a polynomial function. The very last term should either have a positive exponent of x or no x at all. The exponents have to be whole numbers, not negative numbers. So this is actually another example where we cannot put into standard form. With that said, I promise you that last one can be. This last one can be written in standard form. It just looks kind of crazy. Highest degree goes first, or highest exponent goes first. So pi x squared minus 0.5x minus root 2. Degree is the highest exponent. The type is what we typically call it, or what you will hear me call it. Degree of 2 is a quadratic function. And leading coefficient really tells us whether or not it's going to be a reflection or if it's going to be like a regular parent graph. And the leading coefficient here is a positive pi. So it would open the way the parent graph would. Here's what I'm talking about with end behavior for polynomials. This is also in your textbook around page 330. But here's what we need down. We need kind of like a sketch and 2 arrows opening up. That's the most important. 2 arrows opening up. I see this word or this letter n if n is even. This n means degree. So if I were to kind of like translate what I'm looking at, so this n is if your degree of your polynomial is even, so if we're looking at a degree of 2, a degree of 4, a degree of 6, and if your leading coefficient, is positive, then we can say the following end behavior. There's some typos here. End behavior, as we move left on the graph, then we should be going up. And as we move right on the graph, we should also still be going up. So if your degree is even, we should be going up and up. Whether you're an x squared, an x to the fourth, an x to the sixth power, should be opening up and up. If the leading coefficient's negative, then we're going down and down. So if I have a negative x to the fourth, or a negative x to the sixth, my end behavior switches. When our degree is odd and the leading coefficient is positive, then they actually end in different directions. As you move left, you're going down, but as you move right, you're going up. And this is if your degree is odd. So sometimes, here's where I'm talking about, maybe it'll be helpful if we kind of symbolize, hey, this means degree, this means leading coefficient, so in the last case, it gets reflected.